So over the next 3 or 4 lessons, we're going to be looking at the relationship between these 4 functional groups. Only one of them we learned about last year, which is the carboxylic acids. Carboxylic acids are a good group for us to look at because they are the precursor for a few others, and they also have relationships with each other. So we're going to look at how to turn carboxylic acids into acyl chlorides, how to turn them into amides, and how to turn them into esters. We're also going to look at the relationships that these have with each other, if they do it all, and back to turning them into carboxylic acids perhaps. So we're going to be looking at this in a bit of depth. The first relationship we're going to look at is the relationship between carboxylic acids and acyl chlorides. So we're going to have a look at that now. And it's also going to start showing us some of these other reactions or relationships as well. So acyl chlorides look a lot like the carboxylic acids. The difference is they have a chlorine where a carboxylic acid has an OH. So the OH has been substituted out by a chlorine. We've met this before when we're looking at alcohols being turned into haloalkanes. We use a chlorinating agent to do that. So that's one of these 3 things here. PCl5, PCl3 or thionyl chloride. Lucas reagent is not something that will work in this case. Okay, so we're not looking at the zinc chloride and hydrochloric acid. So this substitution reaction will make our acyl chloride. We then need to know how the acyl chlorides will react, so can they be any use for things? They've got 2 main types of reactions. One is called hydrolysis, hydro-water, lysis breaking. So the water breaks it apart. So we have hydrolysis. And we've got another type of reaction called condensation. And there's 2 good examples for this, which again will show us these relationships. Now, condensation reactions are when you start with more than one molecule, you start with 2 molecules and you end up with 1, and water is left over. So that's what that means. So we've got a big spell, hydrolysis, hydrolysis, breaking using water, and condensation, bringing 2 molecules together and being left over with water. Now, the only thing I will say about condensation is it doesn't have to be water, it can be a small water-like molecule. So the common example here would be HCl. And what we're going to find is, with the reactions of acyl chlorides, you usually get HCl, in fact not usually, you always get HCl as a product. Okay, so let's go through those 2 examples. The first one, hydrolysis, is simply adding water to an acyl chloride. So if we start with ethanoyl chloride, and we were to add water, it undoes what these have done here, so it's also a substitution reaction. 1H and 1O comes in and replaces the replaces the Cl, leaving HCl as a product. This HCl will be a gas, so any time we work with acyl chlorides, we do so in a fume cupboard. You'll often find in exams that they ask that question. What are the safety considerations when working with acyl chlorides? They're always in a fume cupboard because they give off HCl gas, which will dissolve in anything liquid in you, like in your eyes and in your nose and in your mouth and in your lungs, to make hydrochloric acid. Alright, so we always work in a fume cupboard. Condensation, there's 2 examples of this. One is to form esters and one is to form amides. Now, amides and esters are both new compounds to us, so we're going to learn more about them in the next couple of lessons. So I'm not going to write the actual reactions up. All I will say is, again, they make HCl. So we've got ester formation and we've got amide formation. So if I go back to my original little flow diagram type thing, my little reaction scheme, I'm starting to see that I've got, I'm seeing that there is a relationship between these. I've gone back and forward between carboxylic acid and acyl chloride, And I've shown how to turn using condensation, turn an acyl chloride into an ester or into an amide. So I've covered those two already. So your task now is to have a look at those reactions, but we are going to learn about esters and amides independently in the next few lessons as well. So this will all start coming together for you. Okay. Any questions on sort of that little relationship between those things? You'll often find, sorry, there was one thing I did forget, you'll often find that acyl chlorides are stored well away from anything aqueous, so anything with water in it. And if we are using them to make polymers, for example, they're often dissolved in an organic compound, like cyclohexane, for example, so that it doesn't react with any water. It prevents them reacting with water. So you'll often see that. And if we make nylon later in this week or next week, you'll see that we dissolve the acyl chloride for that, to make the polyamide. We dissolve that in something organic so that it doesn't react until the other chemical is available.